Inductive and deductive reasoning in science. In this video, we shall make a short detour into an endeavor that is not about the topics that we talk about in math in the modern world. This is about science. Because inductive and deductive reasoning, these are also the types of reasoning that are behind the construction of the body of knowledge that is science. You are familiar with the word inductive. If you came from STEM, you studied pre-calculus, and pre-calculus had a chapter on mathematical induction. So the induction in that topic has to do with inductive reasoning. And you all studied math in grades 7 to 10. In most instances, when you were doing proving in your geometry class, the type of reasoning that you use there is deductive reasoning. But this time, we shall make a detour into science and show to you how inductive and deductive reasoning take place. So inductive reasoning is a type of reasoning that forms generalizations based on the examinations of specific examples or instances of events. Conclusions produced by scientific investigations are generalizations produced by inductive reasoning. So the activities of observation and experimentations, those things precede the making of a conclusion. And when you come to the point when you had to make a conclusion based on your observations and experimentations, the type of reasoning that is involved there is inductive reasoning. So someone who formally committed to the body of scientific knowledge the propositions that plants are not capable of movement of their own. When I say movement, that means being capable of changing places in space. So someone who formally stated that plants are not capable of movement, it lives and dies where it is planted unless some other forces removed it from its present location, that conclusion is a conclusion arrived at through inductive reasoning. But this is where inductive and deductive reasoning play out its relationship. So those generalizations which were obtained through inductive reasoning became part of the body of scientific knowledge. And they became written in books, they became taught in schools, and this is where deductive reasoning will take place. So inside schools, when you are presented objects and without experimentations and observations, you are able to draw conclusions about these objects based on the generalizations which are now part of science. But these generalizations were produced through inductive reasoning. So let us demonstrate deductive reasoning in science, subjects such as chemistry, for example. Example 1.36, deductive reasoning to make conjectures. What are the essential characteristics of the following elements based on their place or places in the periodic table of elements? Helium, sodium, calcium. The table of periodic elements or the periodic table of elements was introduced to you way back grade 7. So let us look into helium. Where is helium here? That is helium. It belongs to group 18, and this is also what you call the noble gases. The nobility. Okay, so what do we know about the noble gases? The word noble is a clue there. When you are noble, you don't mix with the masses. You belong to the aristocrats. You stay among yourselves. And so being in group 18 or being in the group of noble gases, it does not react or it does not easily react with other elements. Maybe you can produce a situation in order that helium will combine with another, but that would be an extraordinary situation. And probably that is something that does not occur in nature. So overall, helium being a noble gas means it does not chemically react with other elements because it's the valence electrons of noble gases is already complete. It has no more space for other electrons to come in. How about the sodium? Where is sodium here? There is sodium, okay? So let me use the magnifying glass. There is sodium. Where does sodium belong? It belongs in the first column. This is what you call the alkali metals. So those are the clues. Alkali metals. So based on that, we will draw conclusions about the characteristics of sodium, even though we have not seen sodium. So being a metal, that means it is good in conducting electricity and heat. Being alkali, what does alkali mean? Alkali has something to do with hydroxide, OH. So when you react sodium with water, one of the byproduct of chemical reaction would be sodium hydroxide. Now, where is calcium? Okay, so let us go back. The next thing is calcium. Where is calcium here? Okay, there is calcium. Ca. Ca is in the second column or the second group. Hey, this is what you call the group of alkaline earth metals. We have never seen, maybe you have never seen calcium in its elemental form ever. But it doesn't matter because we can tell the characteristics of calcium based on its place in the periodic table of elements. This is deductive reasoning in action. Okay, it is an alkaline earth metal. Metal is the key word. So it has the capability of conducting heat and electricity. Alkaline, another clue. When you react this with water, one of the byproducts would be something that has hydroxide, OH. OH goes with alkaline, and you call that hydroxide calcium hydroxide. What about the earth? So alkaline earth metal. Well, it's something like this. Reacting calcium with water produces precipitates. Precipitates are solid, refined residue from a chemical reaction. And so scientists call it earth because in the old days, when something is earth or considered earth, that means it is solid. And so we were now able to describe the characteristics of calcium, sodium, helium without having seen these elements in their elemental form ever. But we were able to lay down their characteristics based on what we know of the noble gases, of alkaline metals, and alkaline earth metals. And how we produced those conclusions is an example of deductive reasoning.